A tax preparation company builds its entire infrastructure around a single deadline. For most of the year, its online platform handles a steady, modest flow of traffic, people checking old returns, downloading forms, updating account details. Then January arrives and volume starts to climb. February, it accelerates. In the 2 weeks before the April filing deadline, traffic can reach 15 or 20 times what it is in August. Then, almost overnight, it collapses back to nothing. And the cycle repeats. If that company runs its own servers, it faces a choice with no good answer. Provision for August and the April peak takes the platform down at the worst possible moment, when every customer needs it most and trust in the service is on the line. Provision for April, and for the other 10 months of the year, the majority of that infrastructure runs at a fraction of its capacity. Powered on, cooled, maintained, patched, and paid for, to sit mostly idle. This is not a story specific to tax software. It is the story of almost every service that has any variability in demand at all, which is nearly all of them. Before naming what the solution looks like, consider what the problem actually costs. The waste is not just financial. Though the financial waste is real, a company that provisions for its peak is effectively pre-purchasing capacity. It will only need for a few weeks a year. The rest of the time, those servers represent money that is committed, depreciating, and returning nothing. For a company at scale, this can amount to millions of dollars annually in infrastructure that exists primarily as insurance against a spike that may or may not arrive at the predicted magnitude. But there is a second cost that is harder to see. Because that insurance is expensive, companies underbuy it. They provision not quite for the true peak, but for what they can afford to provision for, and then they hope. They build queue systems to delay requests instead of handling them. They shed non-essential features during high-traffic periods. They display wait messages. They do all of this not because it is a good experience for their users, but because the alternative, provisioning honestly for the true worst case, costs more than they can justify for something that might happen a handful of times a year. Both of these costs are symptoms of the same underlying condition. Capacity is fixed, but demand is not. Think about how electricity works in your home. You do not contact the power company at the start of each year and say, "I think I might run my oven, my heating, a washing machine, and several lights simultaneously at some point this winter. Please supply me with enough electricity to cover all of that at all times, regardless of what I am actually doing." You draw power as you need it. Switch on the kettle, current flows. Switch it off, the draw stops. At the end of the month, you pay for what you consumed. The grid holds the total capacity. You access it on demand, and you pay only for the portion you used. No one considers this remarkable, because it is how electricity has always worked. But for computing, for most of the history of the industry, the opposite was true. You purchased capacity in advance, you committed to a fixed ceiling, and whether you used it or not, you paid for it. Elastic capacity is what happens when computing starts to behave more like electricity. In cloud infrastructure, elasticity means that the capacity available to your application is not fixed. It expands when demand rises and contracts when demand falls. The expansion and contraction happen automatically, in near real time, without anyone making a manual decision in the moment. And crucially, you pay for the capacity you used, not the capacity you theoretically might have needed. Return to the tax preparation company. In a cloud environment running with elastic capacity, August looks like August. The infrastructure is small because the load is small, and the bill reflects that. January, the infrastructure begins to grow as traffic grows. In the final 2 weeks of March, it reaches its peak, perhaps 20 times the August footprint, and the platform handles every request without degradation, because the capacity expanded to meet the demand. Then, April 16th arrives, traffic drops, and within hours, the infrastructure contracts back toward its baseline. The company pays for what it actually used across the year. Not for April's capacity in August, not for August's capacity in April. This is a meaningful change. Not a technical refinement, but a shift in the economic logic of infrastructure. Capacity stops being a capital commitment, something you buy, depreciate, and hope you sized correctly, and becomes a variable cost, one that tracks actual usage, the way your electricity bill tracks actual consumption. Here is the nuance worth understanding, because elastic capacity does not arrive automatically the moment you move an application to a cloud provider. Elasticity is a behavior that emerges from two things working together: a cloud infrastructure that can provision and release capacity dynamically, and an application that is designed to run across a variable number of instances. Both are necessary. Neither is sufficient on its own. An application that was built to run as a single process on a single machine, where all the state lives in memory, where everything is tightly coupled to one running instance, cannot become elastic by moving it to the cloud. The infrastructure can offer to give it more machines, but if the application cannot distribute its work across them, those machines accomplish nothing. Elastic capacity therefore requires applications to be architected in a particular way, broken into components that can each scale independently, designed to share no state that cannot be accessed from any running instance, built to assume that at any given moment there might be one copy of a service running, or 10, or 100. This is a meaningful design constraint. It changes how databases are structured, how sessions are managed, how services communicate with each other. The tax preparation company that moved to the cloud and gained true elasticity did not just change its hosting provider, it rethought how its software was built. What you understand now is that elastic capacity resolves the oldest tension in infrastructure planning. Demand is variable, but traditional capacity is not. The cloud does not eliminate that variability. Demand still spikes, and spikes are still unpredictable. What changes is that variability no longer has to be absorbed in advance through over-provisioning and waste, or managed through compromise and degradation. The infrastructure moves with demand. The cost moves with usage. The ceiling, for the first time, is not something you have to negotiate with in advance. It is something the system adjusts for you, automatically, as the situation changes. That adjustment, and what drives it, is where the mechanics get interesting.